For this warm-up, I'm going to show you one decimal version and one fraction version. On number 6, please make sure that when you are using decimal addition, you line up the decimal places. To put in a place value spacer so that they are matched up. 4 plus 0 is 4. 2 plus 4 is 6. 4 plus 8 is 12. 1 plus 3 is 4. So this should say 4264. For the fraction piece, I'm going to work with number 3. If I add 7 and 4 together, that gives me 11. If I combine 5/8 and 7/8, that gives me 12/8. But this is more than one whole. That would increase it to 12. 8/8 makes a whole, and we have 4 extra eighths, which can be reduced to 1/2. So we have 12 and a half. Please complete 1, 2, 4, and 5 on your own. Decompose 3.4 in as many ways as you can. 3.4 could be the same as 3 plus 0.4, 2 plus 1.4, 1 plus 2.4, could be 3.2 plus 0.2, it could be 3.1 and 0.3, it could be 2.4 and 1. There are many ways to decompose 3.4. We could continue this list on and on. The easiest way to put 3.4 on a number line using those decompositions is using 3 and 0.4. So we're going to move from 0 over 1, 2, those are halves. We need to go over 1, 2, 3, and then 0.4. 0.1, 2, 3, 4. So you can see here we have 3.4 on the number line in purple. Start to think about how we would decompose the opposite of 3.4, or how we would decompose negative 3.4. Here I have two possibilities. It says examine the following number bonds and determine which is the correct way to decompose negative 3.4. Justify your choice by modeling the values on a number line. Is negative 3.4, negative 3, and positive 0.4, or negative 3 and negative 0.4? Well, to get to negative 3.4 on the number line, we would start at 0 and go negative 3, and then continue 0.4 past that to get negative 3.4, which means to the left 3 and to the left 0.4. So B is the correct number bond. Use the provided number line to answer the following questions. What is the additive inverse of 3.4? Plot a point at the additive inverse on the number line. The additive inverse is the fancy math way of saying the opposite. When we add those two together, we should end up at 0. So we're plotting negative 3.4 on the number line. Using a different color, plot a point at negative 1.2. Here we would have negative 1, negative 1.1, negative 1.2. What is the additive inverse of negative 1.2? That would be positive 1.2. Plot a point at the additive inverse in the same color as part B. So 1.2. Write a number sentence showing that 3 and negative 3.4 are additive inverses. When we add them together, they equal 0. Then do the same thing for negative 1.2 and 1.2. What do you notice about the additive inverses on the number line? They are the same distance from 0, but in opposite directions. For problems 4 and 5, use additive inverses to write an equivalent expression that is simpler to evaluate. So I have 3.4 can be decomposed into 2 and 1.4. Negative 8.2 could be negative 7 and negative 1.2. Here, these additive inverses make 0, so our final answer would be 2. And these additive inverses make 0, so our final answer would be negative 7. Evaluate the following expression. I have negative 3.4 and negative 1.4, so I'm going farther into the negatives. I went 3 and 1, which would be negative 4, and I went 0.4 and 0.4, which would be 0.8. For problems 7 through 14, evaluate the expressions. There we have 0, so this would be 2. Here is 0, so this is negative 7. Here I separated it out into fractional pieces and whole number pieces. We can combine these two. 9/10 and backwards 3/10 would leave us with 6/10. The 9/10 is longer and it's positive, so our answer for that section would be positive. Plus we still have the 1. So this is 1 and 6/10, or you could reduce it to 1 and 3/5. For number 10, we can separate it out. We have 23.5 plus, we can make it negative 23.5 and negative 10. Negative 23 and negative 10 would make negative 33. These are additive inverses, which mean they add up to 0. And 0 plus negative 10 makes negative 10. Let's separate this one out into the whole numbers and fractions. Be careful on this one. This is negative 1 and 1/3. Remember, in our number bond from the earlier problems, both of those parts are negative. I have negative 1/3 and negative 1/3. which makes negative 2/3. I have negative 1 and negative 5, which makes negative 6. So this answer would say negative 6 and 2/3. This would be 2 and negative 3/4 plus a positive 3 and a positive 1/4. Negative 2 and 3 combine to make 1. Right, we'd go backwards 2 and forwards 3, so we'd end up at 1. This one we would go backwards 3/4 and forward 1/4 for a total change of backwards 2/4. If I have 1 and I go backwards 2/4, we can make this be a whole, rewritten as 4/4. And then if we go backwards 2/4, that leaves us at 2/4. Or we can rewrite it in reduced form as 1/2. Negative 4 plus negative 1/4 plus negative 2 plus negative 3/4. These combine to make negative 6, and those combine to make negative 4/4. That is again one whole. Negative 6 and negative 1 combine to make negative 7 for number 13. Here I have positive 4, positive 2/3, negative 3, and negative 1/3. 4 and negative 3 would leave us at positive 1, 2/3, and then backwards 1/3 would leave us with a positive 1/3. So our final answer for 14 should say 1 and 1/3. For problems 15 through 17, analyze Eve's work. Eve's work says negative 2 and 3/4 plus 3 and 1/4. She separated out the negative 2 and 3/4 into negative 2 and negative 3/4, and she split the 3 and 1/4 into positive 3 and positive 1/4. Then she combined the negative 2 and the positive 3, and the negative 3/4 and positive 1/4. Negative 2 plus 3, she said, is 1. Negative 3/4 plus 1/4, she said, was negative 2/4. And when we combine those, she got 1/2. Did Eve's sum from problem match your sum from problem 12? Yes. We also got 1/2. Why can Eve find the sum like this? What is her thought process? She just decomposed the mixed numbers into whole numbers and fractions. Use Eve's strategy to find the sum of this expression. So she rearranged the whole numbers together and the fraction pieces together. Four plus negative 3 is 1. 2/3 plus negative 1/3 is 1/3. for a final answer of 1 1/3. Use the number line to find the sum of the following expression. We start at 0, and we will go to the right 4 2/3. You can see they're split up into sections of thirds, 1/3, 2/3, a whole. Then we have plus -3 1/3. So we're going to go backwards 3 1/3. Each whole number should be 3 marks. So we have 1, 2, 3. That would be 1. 1, 2, 3 for 2. 1, 2, 3 for 3. And then we need to go backwards 1 additional third. So 1 more mark. And that leaves us here, which is 1 and 1 mark out of the 3 to get to the next hole. For problems 19 through 24, find the sum. At noon, the temperature was -4.5 degrees Fahrenheit. 4 hours later, the temperature had risen 10 degrees Fahrenheit. What was the temperature at 4 p.m.? So we started at -4.5, and the temperature has risen, so that's an increase of 10 degrees. We can split this up into multiple parts. 10 can be thought of as 4.5 plus 5.5. These are additive inverses, which make 0. So the temperature at 4 p.m. is 5.5 degrees Fahrenheit. At 8 a.m., the temperature was -14.5 degrees Fahrenheit. 2 hours later, it had risen 3.5. What is the temperature at 10 a.m.? We started at -14.5. We rise 3.5. Let's break this up into -3.5. And to get 14 with the 3, we would need -11. -3 and -11 make -14. These two are additive inverses. So our final answer will say that it was -11 degrees Fahrenheit. We can split this up into -7/8, 7/8, and 2/8 because 7 plus 2 would make the 9. Those are additive inverses, so our final answer is 2/8. These are both going the same direction. We're going left 1.2 and left 2.5. 2 and 1 make 3. 5 and 2 make 7. And it's going to the left. Let's break up 3.4 into 1.3. To get the 3, we would still need 2 holes. To get 0.4, we would still need 0.1. And we have the -1.3 there. These are additive inverses. So the answer to 23 should be 2.1. We're going left 7/5 and left 3/5. 7 and 3 make 10. 5 fits into 10 2 whole times. Make sure your warm-ups are complete and your workbook is filled in.